Okay, today we're going to start looking at relationships between chords, secants, and tangents of a circle and finding those segment lengths. So let's start with the chord-chord theorem. So the chord-chord theorem, the chord-chord theorem says that if two chords intersect inside the circle, then the product of the measures of the segments of one chord is equal to the product of the measure of the measures of the other chord. So what this looks like is if I have a circle, so remember chords are segments inside the circle that don't go through the center. So let's call this A and B. Let's call this C and D. So A times B is equal to C times D. Okay, so that is the chord-chord theorem. So this part times this part is equal to this part times this part. Okay, let's take a look at the secant theorem. Okay, so remember secants make external angles. So two secant segments are drawn from an external part to a circle, then the product of the measures of one secant segment and its external part is equal to the product of the measures of the other segment and its external part. Okay, so let's draw a picture. So you've got two secants. Let's call this B, C, D. So here's your external parts of your secants. Here's your internal parts, because this is technically a chord. So remember, the internal part of a secant is a chord. So this is saying that the whole distance, so PB, segment PB, times the external part, so PA, segment PA, is equal to the whole over here, so segment PD, times the external segment PC. Okay, so that's secant, secant. And then the last one is the tangent secant theorem. So this says if a tangent segment and a secant segment are drawn from an external point to a circle, then the square of the measure of the tangent segment is equal to the product of the measure of the entire secant segment and its external part. Okay, so in this one, we've got a tangent and a secant. So here's our tangent. PT is the tangent. And then let's call this RQ. Okay. So PR is the secant. PT is the tangent. So the tangent is the square. So PT squared, so segment PT squared, is equal to the whole secant, so segment PR, times the external, which is PQ. Okay, so now we are going to practice these. So those are your three rules. So you just have to identify which one is happening, and then you're doing a whole lot of multiplication. Okay, so let's take a look at some examples here. Okay, so this is a chord. Okay, so our rule says that 9 times x is equal to 15 times 12. So that's 9x. 15 times 12 is 180. Divide by 9. And x is 20. Here, this is a secant. So the secant says the whole, so 10 plus 6 is 16, times the external, which is 6, is equal to the whole, so in this case, x plus 8, times the external, which is 8. So here, this is 96. I'm going to distribute, so 8 times x, 8 times 8. I'm going to subtract 64, divide by 8, and I get 4. Okay, so just a whole lot of multiplication. All right, so now let's see what a tangent secant looks like. Okay, so this would be a tangent secant. So this one says that the tangent is the square, so 2 squared is equal to the external part times the whole, so x plus 3 in this case. So this is my square, and then the whole would be x plus 3. Okay, so this is 4. I'm going to distribute. So x squared plus 3x. So this is a quadratic, so I'm going to move the 4 over and factor. So I'm going to have x squared plus 3x minus 4 equals 0. So I'm looking for two numbers that multiply to negative 4, add to 3. So let's see, that's going to be x plus 4 and x minus 1. So if I set this equal to 0, I get x equals negative 4. If I set this equal to 0, I get x equals 1. And I'm going to throw away negative 4 because it can't be, we can't have a negative side length. So x has to equal 1. Okay. So why don't you try these three real quick, and then I'll show you what answers I got.